All right, let's talk about how to find the area of a triangle. So we talked about how the sides relate and how the angles relate. I'm going to start off with this nice and neat 90-degree right triangle. Okay. Remember what area means. Area means how much space this triangle takes up. And we measure area in square units, whatever we measured this in. So I measured this one happens to be, I measured it in inches. This is 3 inches. This is 4 inches. So when I measured that, I used a ruler. I used this ruler right here, and I measured 3 inches along a straight line, right, from 0 to 3. I measured 4 here, and this was actually 5, but that doesn't matter for this. Here's the thing. So when I ask how much space it takes up, I'm not talking about how many inches it takes up. That doesn't make any sense. I'm asking now how many square inches it takes up. So how many squares, if I drew squares in here, maybe I should draw that in here. Here's an inch there, here's an inch here, here's an inch here. And when I draw it this way, and I connect them, it's actually going to make squares. If I drew this straight up now on my triangle, you'll notice that this actually makes squares inside my triangle. I actually have, I have squares inside my triangle. So my question now is, how many squares are there inside my triangle? How many squares does my triangle take up? It's kind of hard to count them. I could try counting them, but well, I can only have, there's only 3 that are whole. These ones out here aren't complete squares, so it's kind of hard to count them when they're not complete. So here's what I can do. All right, turns out that I could make this. I'm going to cheat. If this were a rectangle, it'd be really easy to find out how many squares there were. Huh? If this were a rectangle, I'm going to go ahead and cheat and make it into a rectangle. Well, that wasn't a very good drawing there. All right, let me change this a little bit, make sure it looks more like a rectangle. There. All right, if I made this go up a little bit more, then it would be a rectangle. It'd be really easy to find out how many squares it would cover. I could just literally count them. So it'd be like this. Right? It's really easy to find the area of a rectangle. You just literally count the squares that it covers. So if a rectangle, and I measured 4 going this way and 3 going this way, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the rectangle has an area. 12 square inches. I need to get something to drink. There we go. Okay, so for this rectangle has an area of 12 square inches. And this up here is also 3, and this up over here is 4 inches. Okay, and that's the definition of a rectangle, so they have to have the same lengths on opposite sides, as well as they have to have 90-degree angles. Okay. But I didn't want the area of the rectangle. I only wanted the area of this triangle. Well, guess what? Turns out, this side, since it's a rectangle, this side is the same length as this side. And this side is the same length as this side. And this side right here is obviously the same length for both these triangles. So because the two triangles have exactly the same sides, they have to be exactly the same size. Right? These triangles are exactly the same size. It's like you took this triangle, flipped it upside down, and put it on top of itself. So that means that if I divide my rectangle exactly in half, I will get my triangle. Okay? So my area of the rectangle, you remember, was 12. And I have to find that by multiplication. I have to count. I can multiply 3 times 4 and get 12, right? So my area of my rectangle, was 3 times 4, which was 12. You'll see that often called length times width, or length times height. I kind of like length times height. I'll use that. Okay, area of a rectangle is length times height. Area of a triangle is going to be that same rectangle, but then we're going to cut it in half along the diagonal, right? So the area of a triangle, the formula is length times height, again, but divided by 2. In this case, I will have 3 times 4, but then divided by 2, which gives me 12 divided by 2, which is 6 square inches. Okay. So that's how you find the area of a triangle. You make it into a rectangle, count the squares, and then take half of that. That's how you do it conceptually. Now, mathematically, you take the length times the height times length, or length times width, and divide it by 2. Now, that works if it's a right triangle. What if it's not a right triangle? What if it's a triangle like this, which is an acute, or a triangle like this, which is an obtuse? Turns out you have to make it into a right triangle. There's no way to make a rectangle unless it has 90-degree angles, right? A rectangle has to have 4 90-degree angles. So I'm going to draw a 90-degree angle. I'm just going to take one of my sides, any side I want. I usually say take your long side, makes it easiest, and draw a straight line coming right up the top that goes through the corner of the other one. All right? So that goes through that corner, and it makes 2 90-degree angles. Anytime you take a straight line that's 180, and you cut it in half, it makes 90. And now I've made the problem I had before, right? A 90-degree angle, 90-degree triangle. Actually, I have 2 of them. So this one here on the right can become a rectangle if I take it and I flip it over on top of itself. And this on the left can become a right triangle if I take it and turn it over and flip it on top of itself. And I can't draw a rectangle for some reason, that's okay. You have to bear with me. And now I have a rectangle that measures the length of this triangle and this are exactly the same. And this one and this one are exactly the same. Okay? So if I find this huge thing and I divide it in half, I will get the length of the area of the triangle. Now, what is the height of, I got the length of this rectangle, it's this thing right here, this is the length of the rectangle. What's the height of this rectangle? Well, it's this height right here, right? It's not the length of this side, that's not the height. And it's not the length of this side, that's not the height. The height has to be coming up at a 90-degree angle from the length. I always tell my students, watch for this sign right here, watch for the H for height. You'll notice this 90-degree angle makes a little H. That stands for, that's your height. Well, I tell them that's what it stands for, right? So your height is this line right here. This is your height. So I measure this, and I measure that, and I multiply by them each other, and then I divide by 2, I'll get the area of the triangle. And that works for obtuse angles as well, obtuse triangles. I will just take my long side, put a straight line up from the bottom that goes to the next point, like that. Now that is a height. See that? That is my height. This right here is my height. This is my length. This whole thing down here is my length. And my area would be length times height, but then divided by 2. Because again, conceptually what I'm doing is I'm taking it, this whole triangle divided into 2 right triangles, and I'm taking this right triangle and flipping it up on top of itself, and taking this right triangle and flipping it up on top of itself, making this huge rectangle that measures length times height, and then I'm taking half of it, because I only want this half. I don't want that half, and I only want this half. I don't want that half. Right? So that's how you find the area of any triangle. So all triangles, there's only 2 cases. Either it's already a right triangle, which you're ready to go, or it can be cut in half to make 2 right triangles. And then you're ready to go again. But you got to find that height. All right, that's area of triangles. That's going to be important because every other shape, I alluded to this in the first video, every other shape that's not curvy can be made out of triangles, or it can be cut into triangles.